Hi, good morning. I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Ministry of Aeronautical Engineering, Dundigal, Hyderabad. In this present video, I would like to discuss the problems in Module 1 of Differential Equation of Part C in the question bank. So, in the question bank Part C of the first module, all are definitions and small answer problems, and I will discuss these one by one. And what is a differential equation? So this is ODE, ordinary differential equations. Define differential equation. So differential equation means an equation involving differential coefficients is called a differential equation. An equation involving differential coefficients is called a differential equation. Or in other words, I can say that if y is equal to f of x is any given function and x is the dependent variable, x is the independent variable, and y is the dependent variable, because y is depending on the values of x, y is the dependent variable. And suppose if the derivatives have reference to independent variable x of any order, suppose if it is dy by dx or d square y by dx square, and the equation involving these terms, d square y by dx square plus 2 into some dy by dx plus 3 into y is equal to some cos x. This is called the differential equation. So here the derivatives are reference to the independent variable x and the derivatives are with respect to y with respect to x, then this equation is called the differential equation. And there are two types of differential equations. One is ordinary differential equations and other one is partial differential equations. There are two types of equations. One is ordinary differential equation and other one is partial differential equation. So what is the ordinary differential equation? Suppose if in the given differential equation, the derivatives in the given differential equation have reference to single independent variable, then the equations are ordinary differential equations. The derivatives in the given differential equation have reference to single independent variable. Suppose if in the equation d cube y by dx cube plus 3 into d square y by dx square plus 4 into dy by dx plus some 3y is equal to e power x. So clearly this differential equation, the y is the dependent variable and x is the independent variable, and the derivatives with reference to single independent variable through with respect to x only. So these equations are called ordinary differential equation. The derivatives in the given differential equation have reference to single variable, here dx cube, here dx square, here dx. All the derivatives are with respect to x only. So these type of differential equations are called ordinary differential equations. Then what is the partial differential equation? Suppose the derivatives have reference to two or more independent variables, then that equation is called partial differential equation. The derivatives have reference to two or more independent variables then that equation is called partial differential equation. For example, dou square u by dou x square plus dou square u by dou y square is equal to some n into u. Clearly, it is also a differential equation because the derivatives are existing in the given equation. This is second order derivative of u with respect to x, and here also dou square u by dou y square. This is also second order derivative with respect to y, and right side n constant and u is the function of x comma y. So in this equation, the derivatives are reference to two variables, two independent variables, because here u is a function of x comma y. Here x and y are independent variables. X and y are independent variables, and u is the dependent variable. U is the dependent on x and y, and the derivatives in the given equation is with reference to x and y. So this is called a partial differential equation. So there are different methodologies to find the solutions of ordinary differential equations and as well as partial differential equations. So the differential equations have reference to single independent variable, then that equations are known as ordinary differential equation. In the differential equation, if the derivatives have reference to two or more independent variables, then the equation is called partial differential equation. Now, what is the order and degree of the differential equation? Suppose if the given equation is d square y by dx square plus 2 dy by dx plus 3y is equal to e power x. In this, the highest derivative occurring in the given equation is second order derivative. This is the second order derivative. This is the first order derivative. The highest derivative occurring in the given equation is d square y by dx square. So the order is equal to the second order derivative, that is equal to 2. And degree, what is the degree of the differential equation? The highest order derivative power, that is called the degree of the equation. So order is nothing but, the order of the differential equation is nothing but the order of the highest derivative occurring in the given equation, given in the differential equation. And the highest order power is known as the degree of the differential equation. Now, the differential equations can be formed by eliminating the arbitrary constants. Suppose if the given equation, just I will tell the methodology. Already we solved this problem in the previous video. Just I will go through this method. So the given equation is ax square plus by square is equal to 1. This is the given equation. And what is the given in the given equation? A and b are arbitrary constants. We have to eliminate a and b and we have to form the differential equation. So we need to eliminate two arbitrary constants, and that means what you have to do is you have to differentiate the given equation, differentiate equation 1 with respect to x 2 times. That is, on differentiating with respect to x, a into 2x plus b into 2y into y dash is equal to 0, and this is second equation. And differentiating with respect to x. And differentiating again you will get 2a plus b into 2 into y dash. So y dash whole square. This is uniform. And differentiating y, the derivative is y dash, and y dash treat as fixed 1. So y dash whole square plus y treat as fixed 1 and y dash derivative y double dash, that is equal to 0. So we have obtained 3 equations. Using 3 equations, you form the differential equation. So the element of a comma b is given by determinant of a coefficient x square, b coefficient y square, constant 1. Similarly, it is 2x and it is 2y dash, this is 0. And last 2, and it is what the coefficients y dash square plus 2y double dash, and last term 0. And this is equal to 0. The element of a comma b is determinant of the coefficients of a comma b in the given 3 equations. So now on solving, So 1 is the only factor, remaining 2 terms are zeros. So we'll get only one term, 1 into 2x into 2y dash square plus 2yy double dash minus 4 into y dash is equal to 0. 1 into, on discarding this column and this row, the determinant value 2x into this one minus 2 into 2y dash, or 2 common, I'm taking out 4xy dash whole square plus 4xy double dash minus 4y dash is equal to 0. Or 4 I'm taking outside, x into, what is y dash? X into, what is y dash? dy by dx whole square plus 4xy into d square y by dx square minus 4y into, what is y dash? dy by dx is equal to 0. So this is the given differential equation which is formed by the element of a comma b. So just to eliminate, so you have to observe how many arbitrary constants are there in the given equation. Here there are 2 constants. So to form the differential equation, you are to suppose to eliminate a and b. To eliminate, we get the equations by differentiating one after one, and the element is determinant of this one is equal to 0. And the differential, the 7th problem, the differential equation of the function y is equal to a into e power minus 2t plus b into e power 3t by eliminating the arbitrary constants. Similar problem. Here also a and b are 2 constants. We eliminate a and b by differentiating. Similar model. You can solve the equation. So I will just tell you. So first find with respect to x derivative. This is called one equation. What is dy by dx? A into minus 2 into e power minus 2t. The derivative of e power minus 2t is minus 2 into e power minus 2t plus b into 3 into e power 3t. So this is called the equation number 2. Similarly, you differentiate again. On differentiating, you get d square y by dx square, or I will write here d square y by dx square, or sorry, du square y by dt square, because the variable is d square y by dt square is equal to. So what is this here? Minus 2a constant, again minus 2 e power minus 2t. And here already 3b constant, again 1 3 will come, 9b into e power 3t, and right side this is equal to, right side this is only, or d square y by dt square is equal to 4a e power minus 2t plus 9b e power 3t, and call this is equation number 3. Now we can eliminate the constants a and b from the 3 equations by using the determinant, or by using the algebraic addition and multiplication. We can find the required solution, and that will be leave as an exercise for the students. So you have one equation. This is already I have done the differentiation, and d square y by dx square also I have d square y by dt square also calculated. The value is 4 into a into e power minus 2t plus 9 into b into e power 3t. Now the element of capital A comma capital B from the 3 equations will be the required solution of the given differential equation. Now solution means here the given differential equation. Similarly, write the differential equation for the family of straight lines. What is the family of the straight line? Y is equal to mx. By eliminating m, you will get the differential equation. On differentiating dy by dx is equal to m into 1. So replace m by, replace or substitute 2 in 1. Then y is equal to x into dy by dx, or y dx minus x dy is equal to 0, which is the differential equation of the family of the straight line y is equal to mx. This is the family of straight lines. There are different families. Y is equal to mx is the family of straight lines passing through origin and slope m. Similarly, you can find x by a plus y by b is equal to 1 also is a family of straight line. Similarly, y is equal to mx plus c is also family of straight line. So I have taken y is equal to mx and the differential equation is y dx minus x dy is equal to 0. Similarly, here also form a differential equation by eliminating a. R is equal to a 2a into sin t minus cos t. So you have to eliminate 2a or a, that can be done by differentiating dr by dt is equal to 2a into sin t derivative cos t and cos t derivative minus sin t, that is plus sin t. One, equation number 2. Now what is, I can write 2a is equal to dr by dt into 1 by cos t plus sin t. Equation number 3. Now substitute equation 3 in 1. Then 1 implies r is equal to dr by dt into cos t plus sin t into sin t minus cos t. 2a plus now I replace dr by dt into 1 by cos t plus sin t. So this is dr by dt into 1 by cos t plus 2a. This is, so instead of 2a I substitute dr by dt, not this is 1 by cos t plus sin t and into sin t minus cos t, which is the differential equation of the given function r is equal to 2a into sin t minus cos t, and which is the element of a. This is the formation of the differential equation by the elimination of a. And see the next problem. Solve the differential equation dy by dx is equal to e power x minus y plus x square into e power minus 1. So I will solve this equation. So the given equation can be written as dy by dx is equal to e power x by e power y plus x square by e power y, or dy by dx is equal to x square plus e power x, numerator, the denominator is e power y. So on separating the variables, e power y dy is equal to x square plus e power x into dx. So on integrating, integral e power y dy is equal to integral x square dx plus integral e power x dx plus c. Then what is the solution? E power y integration, e power y, the x square integration x cube by 3 plus e power x integration e power x plus c, and which is the required solution of the given differential equation. So next, on coming to the 11th question, 11th definition, define the homogeneous differential equation. When we say that an equation is said to be a homogeneous differential equation, so before going to homogeneous differential equation, I have to define homogeneous function. Suppose if I take x square plus y square, it is a homogeneous function of degree 2. Because in all the terms in the equation, all degree 2, same degree, it is a homogeneous. Homogeneous means like. So it is second degree, So it is a homogeneous function of degree 2. Similarly, x square plus y square plus 2xy, it is also a homogeneous function of degree 2. First term 2 degree, second term 2 degree, third term 2x power 1, y power 1, 1 plus 1 degree 2. So it is also a homogeneous function. So in definition wise, how we can say that f of xy is said to be a homogeneous function if f of kx comma ky is equal to k power n into f of xy. If we write like this f of xy, then it is a homogeneous function of degree 2. For example, f of kx comma ky is equal to, on substituting, k square x square plus k square y square. Or I can write k square into x square plus y square. And that means what? K square into f of x comma y. This is k square into x square plus y square means f of xy. K square into, I will write this I can write it is k square into f of xy. So it is looking like k power n into f of xy. So it is a homogeneous function of degree 2. So now a differential equation is said to be homogeneous differential equation if it is in the form dy by dx is equal to f of xy, where f of y is a homogeneous function of degree 0. If the right side function is a homogeneous function of degree 0, then it is said to be a homogeneous differential equation. For example, dy by dx is equal to x square plus y square by 2xy. It is a homogeneous differential equation because it is a homogeneous function of degree 0. In the numerator it is 2 degree, in the denominator it is 2 degree. So I'm writing in the numerator it will get the degree 0. So it is a homogeneous function of degree 0. So entire differential equation is a homogeneous differential equation. So when we define a homogeneous differential equation, the definition is a homogeneous differential equation is an equation of the form dy by dx is equal to f of xy, where f of x comma y is a homogeneous function of degree 0. So already example also given, this is a homogeneous differential equation. And also I can write another example, 2 example. Dy by dx is equal to x square minus y square by x square plus y square. Because it is a homogeneous function, 2 degree, remainder 0, homogeneous function of degree 0. So it is a homogeneous differential equation. Next, what is the condition of exactness? I will give, suppose let m dx plus n dy is equal to 0 be the given differential equation, where m comma n are functions of x comma y. The condition for exactness. What is the exact equation? This is a differential equation. A differential equation which is obtained from its primitive by direct differentiation and there is no further operations are used is called exact differential equation. So how to check the condition? How to find the differential equation is an exact or not? That can be done by using the condition of exactness. So that I am telling you. Suppose if m dx plus n dy is equal to 0 is the given differential equation, and find dou m by dou y and dou n by dou x. If these two are equal, then we say that the equation is exact equation. Exact means the equation is obtained from its primitive and there is no further operation is used. If it is not obtained from its primitive directly, it is not exact equation and it can be made exact by using integrating factors. Right. Suppose if I take y dx plus n d, I will write one example, y dx plus x dy is equal to 0. Here what is m is equal to y and n is equal to x. Dou m by dou y, that is equal to 1, and dou n by dou x also 1. So then what I will say that it is an exact equation. Because it is obtained from its primitive, d of xy 0. So it is obtained, this equation obtained by differentiating xy is equal to c directly. Xy is equal to c if you take the primitive, then on differentiating x into dy plus y into dx constant derivative 0. So on differentiating x into y is equal to c, you will get the differential equation and this equation, obtained equation is an exact equation. That is the example for the exact equation also. Then when coming to the 13th problem, define a linear differential equation of first order. So what is the standard form of the linear differential equation? An equation is of the form dy by dx plus p of x into y is equal to q of x. Where p of x comma q of x are functions of x. Where p of x and q of x are called functions of x is called a linear differential equation of first order in y. first order in y. If the given equation is linear differential equation of first order, then you can find solution easily. The solution will be y into e power integral p dx is equal to integral q into e power integral p dx dx plus c. And this is the general solution of the first order linear differential equation. Next, I'm coming to write the form of Bernoulli equation. What is the Bernoulli equation? An equation is of the form dy by dx plus p of x into y is equal to q of x into y power n. This is called Bernoulli equation. An equation is of the form dy by dx plus p of x into y is equal to q of x into y power n. If q of x is alone in its right side, then it is called the linear equation of first order. This is Bernoulli equation. So how to solve Bernoulli equation? By reducing this to linear differential equation of first order, we can solve the Bernoulli equation. So the standard form of Bernoulli equation is this: dy by dx plus p into y is equal to q into y power n, where p and q are functions of x comma y. The next definition: what is orthogonal trajectory? What is the trajectory? Trajectory means what? Trajectory. Trajectory means, suppose if you take a family of circles, x square plus y square is equal to a square, where a is the parameter. Clearly it is the family of circles whose center at 0, 0 and there are different radius. This is family of circles. It is called family of circles and whose center at 0, 0 and radius is equal to a unit. Suppose if a curve which cuts every member of the given family according to some definite law, a curve which cuts every member of the given family according to some definite law is called trajectory of the given family. Trajectory. It may be some property. It is cutting the equation with angle theta is equal to 30 degrees. Or it has slope m is equal to some 2. Whatever it is. So if it is proceeding with some definite law, then it is called the trajectory of the given family. Then what is orthogonal trajectory? Suppose a curve which cuts every member of the given family at right angles. Right angles means what? At theta is equal to 90 degrees. If it cuts every member of the given family at right angles, then it is called the orthogonal trajectory of the given family of curves. That is the definition number 15. Find the orthogonal trajectory of the family of straight lines y is equal to ax. Y is equal to ax is a family of straight lines passing through horizon. Or y is equal to mx means it is family of straight lines passing through horizon. So we have to find the orthogonal trajectory of this curve. How to find orthogonal trajectory? First we have to find the differential equation. How to form differential equation? By eliminating a. So dy by dx is equal to a, or from this equation y is equal to a means x into dy by dx. This is first equation. This is the differential equation of the given family. This is the given equation. When differentiating and eliminating a, you will get the differential equation of the given family. Now replace dy by dx by minus dx by dy. Then what you will get? Y is equal to x into minus dx by dy. So this is why you have to done is for orthogonal trajectories. For orthogonal trajectories, replace dy by dx by minus dx by dy. This is slope m. This is minus 1 by m slope. Perpendicular slope. 90 degrees. Then what is the equation? Y dy plus x dx is equal to 0. So integrating, what you will get? Y square by 2 plus x square by 2 is equal to c, or x square plus y square is equal to 2c is the required family of orthogonal trajectories. Clearly it is the family of circles. Family of circles is the family with the 90 degrees. It it will cuts every straight line with 90 degrees. Then the last definition, state the Newton's law of cooling. What is the Newton's law of cooling? If suppose the rate of change of temperature of the body, d theta by dt is proportional to theta minus theta naught. The rate of change of temperature of the body is proportional to theta minus theta naught, where theta naught is the surrounding medium temperature, theta is the temperature of the body at any time. Or d theta by dt is equal to some k into theta minus theta naught. Or d theta by theta minus theta naught is equal to k into dt. The rate of change of temperature of the body is equal to difference of the temperature of the body and that of the surrounding medium. That is the statement of the temperature, the statement of the Newton's law of cooling. So d theta by dt is equal to k into theta minus. This is the statement of the rate of change of the temperature of the body is proportional to the difference of the temperature of the body and that of the surrounding medium. So this is called the Newton's law of. So to find the solution, we will have to find theta in terms of theta naught, and if it gives positive effect, then it is called heating effect. If it is negative, then it is called the negative effect. So with these few definitions and few examples, I conclude my session. And the problems has been taken from the question bank of the course, differential equations and vector calculus. And it is published by IARE and the regulations is BT. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.